Okay, so today we're solving inequalities. Cool. It's a lot like solving equations, except we replaced our equal sign with our less than and greater than signs. So if you remember from 6th grade, the alligator eats the bigger number. So if you want to write these down, in case you forgot somehow, this symbol means less than, and this one is greater than. And if you put one line underneath it, it becomes greater than or equal to. Okay? As far as math, most of what we do is exactly the same, so we still want to get the variable all by itself, want to isolate it. So in our first example, if we have y minus 6 is less than 3, to get y by itself, we would need to do the opposite, so add 6 to both sides. So y, it's going to cancel out. So here, as far as that's different, is we have to be mindful of what our symbol is. So in this case, still going to be less than. 3 plus 6 is 9. Okay. So x just has to be any number less than 9. So if I said, I don't know, 2 is less than 9. If I substitute that back in, 2 minus 6 is -4. And is -4 less than 3? Yes, it is. Okay. You don't have to do it on this assignment, but you will see it a little bit later on this week. If we want to graph this, let's make sort of a lazy graph, totally equally spaced out. The way we graph these, if it's a less than or greater than, you signify that with an open circle. And then since it's less than 9, it's going to be all the values to the left of that. So that is what our graph would look like. Some of these you'll see where they'll actually graph this and they'll put it like on the line, which is nice if you have more than one color, but if you're just using you just have a pencil, it can get a little bit hard to read. So I like to put it just a little bit above the line. Okay. One thing to help you get rid of this box, maybe. No, come on. There we go. Okay. One thing to help you out, as long as the variable is to the left, whichever way the arrow is pointing, like notice less than sort of looks like it's pointing to the left. That's the way the direction our arrow is going to go. So less than is everything to the left, greater than is everything to the right. Okay. So our second one, this is where things get a little bit different. So if we are multiplying and dividing, we still want to get rid of everything on the same side as our variable. So I want to get rid of this times -4.2. So I'm going to divide both sides by -4.2. We're left with x on the left. This actually works out to +7. I don't know why they gave you decimals, but they did. Okay, but here's where, and some of you are like, wait, this is ringing some bells. I've done this before. If you multiply or divide by a negative number, let me write this down. And we can get more technical with this later, but for right now, what we're doing, if you have to multiply or divide by a negative number, you're going to flip the inequality symbol. And running out of room, but that's okay. That's all I got to put. So when we divide this by -4.2, we go from being greater than or equal to actually being less than or equal to. And then this becomes our answer. Okay? So the only time that happens, the only time you're going to flip this is if you multiply or divide by a negative number. Okay? Notice over here we subtracted, we got rid of a negative number, but that doesn't change our sign, we don't care. The only time this switch happens is if you multiply or divide by a negative. Okay. On the other side, or the second half of the questions, if you're doing this online, is the same thing, just with 2 steps. So you can do this the same way we did equations. So if we have 8y minus 9 is greater than or equal to negative 15, we'd start by getting rid of the minus 9. So that's going to be 8y greater than or equal to negative 15 plus 9 is negative 6. And we're going to divide both sides by 8. So we get, it's going to cancel, I cancel 2. Y greater than or equal to negative 6/8 simplifies to negative 3/4, or 0.75, and that is our answer. And if you're saying, Ellis, wait, you had a negative and you divided and you just said to change that. Okay. Well, it doesn't matter what this number is. It's only what we actually divided by. Okay, since we divided by a positive 8, or you can also think of it the coefficient of our variable. If that's positive, sign does not change. The only time it changes is if this coefficient is negative. What we're actually dividing by is a negative number. Okay, nothing else matters. Everything else can be negative. This is the only one that's going to change things. That number in front of our variable. Okay? And really, that's going to be what's going to throw you off today. Nothing. You've done the math hundreds of times this year, so it's really going to be the symbols that we got to practice. Last example, negative 4x minus 13 less than negative 21. So we do plus 13 to both sides. Nice, easy start. That'll cancel. So we have negative 4x, so you should be like, oh, something's going to happen here. We're going to leave it, because we haven't divided by a negative yet. Keep the symbol the way it is for now. Negative 21 plus 13 is negative 8. So now we're dividing by negative 4. So here's your, oh my goodness, something special is happening. So divided by negative 4, these will cancel. We have x is greater than now. Then negative 8 over negative 4 is positive 2. Okay? And then I realized, I can go back and correct this. Let me show you what this graph would look like. Here is negative 3/4. Here's 0, somewhere to the left of it. Here's negative 1, totally spaced out correctly. Don't worry too much about that. If we say greater than or equal to, we show that with a closed dot. And then since it's greater than, that's going to point everything to the right. And the reason behind this, to try to wrap your head around why there's a closed dot and an open dot, is when we say less than 9, you're not actually including the number 9. So it's saying, we're putting our point here, but it's really everything just to the left of it, but not including that one point. Okay? So when we say greater than or equal to, less than or equal to, we use a filled in dot to show that not only is it everything to the right of that point, but it's also including that point itself. Okay? Again, you don't have to graph any of these today, but later on you're going to see it. So I figure why not let you know now. If you want to see, just for funsies, why the sign flips, we can look at our seesaw example, which is an example I just made up. So if I go back, or I'm not even going to put this in. If I say 5 and 2, those are our 2 kids. One's 5, one's 2. And they are on a seesaw, right? Let's actually make a seesaw. So if I put one kid who weighs 5, one kid that weighs 2, let's not worry about what sort of units those are. Who is going to be, or who's going to weigh down our seesaw? And you'd be like, well, that's obvious, Ellis. It's going to be like this. It's going to have 5 here, 2 here, right? The more heavier thing weighs down the seesaw. So I know that 5 has to be greater than 2. Okay, not too bad. You did that 6th grade, maybe even 5th grade. I don't know. But what if someone comes along and says, I want to multiply, come on, give me blue. I want to multiply everything by -1. I'm just going to ruin your recess here. So now we have -5 and -2. So how does that affect our seesaw? So here's our new seesaw. And now our kids weigh negative. So it's like up. Imagine we took our kid and we attached 5 helium balloons to one and 2 helium balloons to the other. So what is going to happen? And if you know anything about helium, you would say that the one with more, come on, you can do it. There we go. It's actually going to lift it up more. So the more negative it is, let's put a, can you put a little balloon here? It's totally perfect. Balloons. Okay. So the more negative it is, it's actually still, I guess you could say, like exerting its influence. Like it's doing the work. Like the 2 is always like, oh, I'm trying, but really it's what the 5 wants is what's going to happen on our seesaw here. So that's why we have 5 or -5 less than -2. Okay. This one's a little bit harder to conceptualize because it involves negative weights on a seesaw, which is not a real thing. But if you can think hypothetically, hopefully it makes a little bit of sense. If that doesn't make sense, take solace that this rule always works. Okay, that's all. Nice and sort of easy. If I can find my button.